Hello and welcome to the July CometWatch. We're a little bit late, but then again, there's so much going on that we figured it's probably best just to leave it to a little bit closer to the end of the month to put in the show out. So, as always, my name is Evetts, 2 Echo 0 Lima Uniform November, or maybe it will be eventually 2 Whiskey 0 Lima Uniform November. I'm sure people out there know exactly what I'm talking about. But would my co-hosts kindly sign in, please?
I'm Mary McIntyre.
And I'm Neil Norman.
Great, welcome. It's great to be back. It seems like we haven't had a chance to do anything like this for ages, even though I know we did a show last month. Just one of those things. Now, whilst I think about it, the AFM website is currently down at the moment, or is right at the time this show is being recorded, which is July 22nd on Sunday at about 18:22 Universal Time, or preferably GMT, as I still prefer to call it. So we are going to put a public post on the CometWatch group on Facebook, on my personal page on Facebook, and if anybody is willing to host the post, please let us know, and I will ask that you keep it as public so it can get as much dissemination as possible. Anyway, with any further ado, let's get on with the show. And as always, we are indebted to Nick James and Jonathan Shanklin for the visual observations page at the British Astronomical Association Comet section. So let's get kicked off. June the 18th, Massonora Ucina reports a Kreutz Group comet in real-time C2 images.
Then June the 20th, Massonora Ucina reports another Kreutz Group comet in real-time C2 images.
And on June the 21st, Massonora Ucina reports a Kreutz Group comet in real-time C2 images.
June 22nd, discovery of 2018 L4 periodic Panstarrs reported.
June the 23rd, Massonora Ucina reports a Kreutz Group comet in real-time C2 images.
And June the 23rd again, Moorshot Bloomplod reports a Kreutz Group comet in real
Sorry, what was that, Neil?
time.
Hello, Neil.
June the 23rd, Moorshot Bloom. Hello, can you hear me?
Yeah, I can hear you now.
Oh, sorry about that. Did that one again?
Yeah.
Sorry about that.
Yeah.
June the 23rd was Moorshot Bloomplod reporting a Kreutz Group comet in real-time C3 images.
June 24th, Rena Cratchit reports a Marsden Group comet in real-time C2 images.
June the 24th, Massonora Ucina reports a Kreutz Group comet in real-time C3 images.
June the 25th, and Massonora Ucina reports a Kreutz Group comet in real-time C3 images.
June 26th, Massonora Ucina reports a Kreutz Group comet in real-time C3 images.
And June the 27th, Massonora Ucina reports two Kreutz Group comets in real-time C2 images.
On June the 30th, Moorshot Bloomplod reports a Kreutz Group comet in real-time C3 images.
July the 1st, Moorshot Bloomplod reports a Kreutz Group comet in real-time C2 images.
July the 1st, Moorshot Bloomplod reports a Kreutz Group comet in real-time C2 images.
Again on the 1st of July, discovery of 2018 L5 periodic Leonard reported.
July the 2nd, discovery of 2018 M1 Catalina reported.
July the 2nd again was Moorshot Bloomplod reporting a Kreutz Group comet in real-time C3 images.
And on the 5th of July, Moorshot Bloomplod reports a Kreutz Group comet in real-time C3 images.
July the 6th, discovery of 2018 N1 Neowise reported.
July the 6th again was Moorshot Bloomplod reporting a Kreutz Group comet in real-time C3 images.
July the 7th, Massonora Ucina reports a Kreutz Group comet in real-time C2 images.
July the 9th, Moorshot Bloomplod reports a Kreutz Group comet in real-time C3 images.
July the 13th, Massonora Ucina reports a Kreutz Group comet in real-time C3 images.
July the 15th, Massonora Ucina reports a Kreutz Group comet in real-time C3 images.
July the 16th, discovery of 2018 N2 Assassin. They're at it again. reported.
And July the 16th, the site was updated.
Now, if there's no recent updates on the BAA site, you can always try the German Comet group or Yasuichi Yoshida's page for more information, or the Liga Iberoamericana de Astronomia for observations. Now we're going to switch to current comet magnitudes, July 15th, and observable region, July 13th. So, let's start with Panstarrs 2016 N1, magnitude 8.5, steady, observable 30 degrees north to 90 degrees south, visible all night. Last visual observation was July 2018.
Then we have Panstarrs 2017 S3, currently magnitude 9.5 and brightening, but we know that's been variable, but we'll talk about that more in a minute. Observable 50 north to 10 south, that's an all-night object. Last visual observation, July 2018.
And next we have NEOWISE 2018 N1, magnitude 10, but it's brightening, 40 degrees north to 80 degrees south, a morning object, last reported in July.
21p, Giacobini-Zinner, magnitude 10, bright, 50 degrees north to 20 degrees south. It's an all-night object. Last observed July 2018.
Then we have Atlas 2017 T3, magnitude 10 question mark. That is steady, currently at poor elongation, so hasn't yet been observed.
Next we have 66p Du Toit, magnitude 11, but now fading, 25 degrees north to 80 degrees south, best viewed in the morning and last seen in July.
37p Forbes, magnitude 12, fade, 50 degrees north to 70 degrees south. It's an early morning object, last observed July 2018.
Then we have 364 periodic Panstarrs, magnitude 12 question mark. That is steady, observable 40 degrees south to 75 degrees south. That's an early evening object, but not yet observed.
Next we have your old friend 2016 R2 Panstarrs, magnitude 12, but now fading, currently at poor elongation and last seen in July.
Next we have Lemon 2018 EF9, 12.5, fading, 50 degrees north to 25 degrees south. It's an all-night object, and it was last visually observed in May 2018.
Then we have Panstarrs 2016 N6, current magnitude 12.5 and fading, poor elongation at the moment. The last visual observation was June 2018.
Next we have 240 periodic comet NEAT, magnitude 13 question mark. It's steady, but yet in conjunction with the sun at the moment, and is yet to be observed.
Next, my favourite, 29p SW1 or Schwachman, 13 magnitude question mark. It varies. It's 50 degrees north to 65 degrees south. It's a morning object, last visually observed 2017 October.
Then we have Panstarrs 2015 01, currently magnitude 13 and fading, observable from 50 north to 0 south. That's an early evening object. Last visual observation was July.
And next we have Atlas 2017 M4, magnitude 13.5 and is steady, 55 degrees north to 20 degrees south, best seen in the evening and last reported in July.
And finally, but not least, 48p Johnson, magnitude 13.5, steady, 35 degrees north to 70 south, best in the morning and last observed July 2018. Now, keep in mind, the observable region is an approximate indication of the latitude at which the comet may be seen. Obviously, under good conditions, comets may be visible outside this range. The period when visible is for the UK, so if the comet is visible from the UK, otherwise for 40 south or the equator as appropriate. The last visual observation is as received by the BAA Comet section. Details are often updated on the basis of observations published elsewhere. And of course, details are normally fully updated at the beginning of each month. Now, highlights and news. Well, there's at least 3 comets in the news. There's 2017 S3, which we're going to discuss fairly shortly. 2017 T3 is reported at 10th magnitude in the twilight. Sadly, it will not become visible from the UK. So this is going to be one we're going to, if you really want to image it, you're going to have to go into your favourite remote telescope that's south of the equator and do it that way. 21p is in the news still. It's supposed to be brightening quite rapidly as its distance from both the Earth and the Sun is decreasing. So, am I going to stick my neck out and say this is going to be naked eye? No. Comets are like cats, as those of us who own them know. Cats do with their tails as they wish, and so do comets. So we can say it's getting brighter. It's predicted. Note the word predicted. To be a binocular object, which is slightly different from naked eye visibility by quite a few rows of peppermint trees. However, wishful sorry, I couldn't resist a little bit of Alice there. But seriously, if wishes were horses, yes, I would wish that S3 certainly and 21p were brilliant naked eye objects, but I don't think we're going to get that. S3 may, and again, I don't mean James May, Captain Slow. I do mean it may brighten enough to perhaps just barely be naked eye, but that is still open to debate, and certainly it's very erratic at the moment. And again, I'm not going to stick my neck out and say it's going to be. It's possible. From what I understand, it has been seen in binoculars, so. There are great hopes. So Neil,
yes,
let's go discuss S3 for a change.
absolutely. What would you like to do, Nick?
Well, this is another one of those green comets, isn't it?
It is a very gassy comet. Yes, it is. It's an Oort cloud object, and it was discovered on September the 23rd, 2017, when it was at that time 5 astronomical units away from the Sun. It was discovered by the Panstarrs team, the Panstarrs 1 telescope in Haleakala, I think it's pronounced, I'm not really sure, in Hawaii. At the time of discovery, it was magnitude 21.5, so very, very dim indeed. But once the orbit had been worked out, it was seen to be a Oort cloud object. Now, the problem with these things is a lot of people may remember, for example, ISON. They tend to be very bright at large distances, come in and then sort of like fizzle out and let us all down, and we get all excited over nothing. Well, this one has been doing how it should have been doing up until the 1st of July, when it was, because I hadn't been following the comet at the time because it was magnitude 12.5, a little bit too dim for me, so I didn't really see it. And then all of a sudden it jumped up to magnitude 8.5 in one evening, and it stayed bright for a few days, and then I think about 72 hours, to be honest with you. Then it dipped back down again, all the way down to about 11th magnitude, which is what it should have been. And then 3 or 4 days ago, on the 16th, it had another outburst, and it went from magnitude 11. And I had a pair of 20 by 80 binoculars because I had such fine weather here recently, clear skies nearly every single night. And I was able to see it at magnitude 7.2, which is very bright indeed, with an elongated coma in position angle 259 degrees, which is correct considering the positioning from the Sun. So the coma should have been stretching out in that direction. The comet is heading, unfortunately, the comet is getting closer and closer to the Sun because it is due to be at perihelion on the 15th of August. But it's going to be at perihelion at 0.2 astronomical units from the Sun, excuse me. So it's going to dip inside the orbit of Mercury, and it should be lost to us in about another week or so's time because of the proximity to the Sun. But from the 25th of August until the 13th of September, those people who follow the SOHO-LASCO field of, which you can do on your computers, you should be able to see the comet pass within that field of view. So we can still follow it then. It's going to spend an awful long time hanging around the Sun from our perspective because we're going to essentially be on the opposite side of the Sun to it. It will then start to at a inclination of 99 degrees, So it's going to be shooting north again, but very, very slowly, as I say, because we are essentially the opposite side of the sun. So it's going to take quite a while for us.
Neil?
Like about, yeah.
We lost you briefly for a few seconds.
Oh, sorry.
You were talking about it beginning to come north again, and that's when you seemed to drop out a bit.
I apologise about that. Yes, it's going to be coming north again.
You've gone very, very quiet, Neil.
Oh, can you hear me now?
That's much better.
Yep, that's better.
Yeah. Sorry about that. Yes, it's going to be coming north, sort of like from about early November. But unfortunately, by then, the magnitude would have dropped down to about 12. It's a very rapid brightener, and it will dim very quickly as well, because we think it's a small object, probably only a few hundred meters in diameter, but it's very, very active, which is something we couldn't see or predict until the 1st of July. So anything could happen. It could quite easily disintegrate the...
You've gone all muffled
small...
again. Now, I've got a question for you, Neil. I know that on Sky and Telescope, they've said that as of July 20th, S3 was at magnitude 7, and then by the 22nd, it's faded again to magnitude 9. And I'm looking at a picture from the magazine showing a very beautiful condensed coma, and which they're saying is something in the order of, where was that information? But they had a very nice ion tail as well, very narrow but nice ion tail jetting off the back.
Yes, that seemed to last for 72 hours. Michael Jäger from Austria took a grand photograph of it. It had a lovely tail. It looked a bit reminiscent of one of Terry's comets, 2013 R1, for example.
Yeah, it's a gorgeous picture because it's next to that lovely blue star. It's a stunner.
It certainly is. And 72 hours later, the tail is gone. It's dimmed by 2 magnitudes, and it's just a faint fuzzy blob again. So I don't know if it's a periodic thing, because obviously we've only seen it do it twice, but it's over a 2-week period. So, and we don't know the rotation of the nucleus yet, obviously. But Michael Jäger did also post a video of the outburst, and you can see the rotation. It appears to be in a clockwise direction, but we'll leave it to the mathematicians who can work out exactly how long. They'll be able to work it out, but I'm sure it seems to be rotating quite quickly, so maybe 12 hours, something like that. I'm not really sure.
It's a shame Brian Marston's not still with us, because I could almost imagine him at this point sitting there scribbling on his pad to work out the figures for this. It's at the drop of a hat. But one of
some optimistic prediction that it might get to mag 3 or 4 on that same article.
Yes, I know.
Yeah, it's actually been updated overnight, and if you got the Soho, I suggest people get on it as quick as you can when the time comes. It's predicted to go up to 0 magnitude, which will make it look very bright in the Soho LASCO images. I spoke to Mike Mayer, who's a great comet enthusiast and has helped Gary Cronk write the cometography books that some people may have at home. And he says he's never known a comet like this, an Oort cloud comet like this, to behave like a periodic comet that goes into outburst and then dims and then outburst and dims. So this is very strange.
This is probably a question I wish we had Richard on the show, because this sounds very much like how SW1 behaves. It outbursts, it drops in magnitude, and then suddenly it outbursts again. Now, could it be that there's an outgassing explosion happening on a cyclic basis due to some mechanism? Obviously, it's heating, something that's heating the crust. There's an extremely weak portion of crust. Could we be getting a SW1 type outburst?
Well, that's it. I mean, it's now dipped inside the sun now to what? It's about 0.7 astronomical units away from the sun, so it's certainly getting quite a bit of warmth now. But yeah, it's, as I say, you never know. I mean, the trouble is when it does it again, if it is a sort of like a weekly or fortnightly thing, it'll be too close to the sun for us to see. So
Yeah.
It could even disintegrate. But it's very unusual. But the thing is, it's definitely an Oort cloud. I mean, it's originally started at around about 2,400 astronomical units away from the sun, so it's drifting around in the Oort cloud. And if it survives, it's a hyperbolic object, so it's going to be shooting off into space. Yeah, it's a one-trip
gone tomorrow.
It certainly is.
It'd be great to observe it from Mercury, wouldn't it?
Oh yeah, or
Yes.
or even maybe the Venus probe will be able to see it. But this is I think this is when you really regret not having a piece of space, a satellite or a space probe just tootling around, waiting for a target to pop up of opportunity, and then you can send it to follow the target as it goes behind the sun. I think that's something maybe that ESA and NASA need to think about doing, is when we get a nice long-range comet that we know is going that could perhaps do an outburst, maybe have it intercepted and followed behind the sun, because that's something that's a place we've never really observed comets before. I know we have the Soho and Lascar, but we would still see the comet go behind the sun, and then we would still have to wait for it to reappear on the other side. But to actually follow the comet around as it's coming in from perhaps Jupiter or Saturn distance, and then follow it out to that distance, and then transmit all that it has learned. There's a Vija reference for you. And then wait for another target of opportunity. Certainly this is something that the new ion engine that NASA has successfully used on New Horizons would definitely be good for. There's a thought, maybe that's something maybe there's a campaign that could be aimed by astronomers, and particularly comet astronomers and researchers, to have NASA and ESA collaborate on, is a space probe that can sit around somewhere near Jupiter, pick up on a comet like S3, follow it into the solar system, follow it behind the sun, and then follow it on the way out as it starts to fade, as it heads out on its either to the Oort cloud or to beyond. It would certainly provide us with a lot of information, I suspect, on cometary behaviour. Sadly, that was something we could not do with Rosetta, which would have been nice if we could, because I think there's a lot of information we just don't have about how comets behave once they go out beyond visual and imaging range. So if you could just follow it behind there, even just to record the disintegration of the comet, that alone would provide us with a lot of information we just currently don't have.
We could learn so much by doing this, particularly not just for one, but if we could have something out there that could do it for several, that would be really educational.
But as I say, I think maybe this is something that can be pointed out to the space exploring community, saying, you keep asking us for ideas. Well, this is the idea. We send something out to say Jupiter, midpoint between Jupiter and Saturn, where we know a comet is going to come through. It follows the comet in. It goes behind the sun with the comet, even if the mission ends at the comet self-destructing behind the sun. We kind of had an idea that Ison wasn't going to survive because we knew it was going to go through the actual solar atmosphere. And when a comet does that, pretty much it's a hasta la vista job. Some comets were strong enough to come back out. That has happened. But to actually be able to do serious science and see and record the destruction of a comet by the sun, that would fill in a lot of gaps in our knowledge. Basically, we need Rosetta 2 and 3, We have
Yeah.
the asteroid recovery missions, Hayabusa.
Yeah.
We have Osiris-Rex going on, which is great. But we need to do this with a comet. We need to follow a comet from as it approaches to as it recedes. That way,
The real gem. Yeah, but I think the real gem at the moment, I was reading some papers during the week, doing some research, and the real gem at the moment seems to be catching these interstellar interlopers, like a Muamua. They seem to be wanting those. So
maybe there's something else that can be used, be a secondary target. If we haven't got a comet that's suitable, if we see one of these interlopers, maybe we can actually get up close, image it properly, and see what we can learn from it, from almost a stationary orbit above it. The first one caught us really with our pants down. Literally. We know these things happen. We think they've happened before. So maybe it's time, for three or four space agencies just to get together and say, well, we can do this. To heck with international politics. Let's just do something for the sheer scientific knowledge. Set up a mission where we have a space probe. It can be either tasked to follow a comet in and out. Maybe on the way out, if one of these interlopers is in an intercept, on a viable intercept, then we can get there and we can do the science there. Even if it means perhaps leaving that being the end of the spacecraft's mission because of the fuel usage. Even with the ion engine, they have limited propellants still. But it means that you have got quite a few possibilities. Maybe if it's sitting there out between Jupiter and Saturn, we could use it to look into the Jupiter family, and maybe image some of the comets which Jupiter has captured and sends into the inner solar system and then recovers. Particularly SW1 really does stand out as being one we could actually do a mission to in the meantime. It would give it something to do when it's not in use. It's a case of, well, okay, what's going on? There's a predicted outburst of SW1. Yeah, we can look at that. We can look back towards home. We can look at that comet. We can do some long-range science whilst we're waiting for an intercept target. It would give an awful lot of people, I think, the information they want, and we know an awful lot about SW1, but we don't know an awful lot about these comets, which are once a time, because they're on a hyperbolic, they're going to go out the solar system. They're going to become wanderers themselves. So somewhere out there's a solar system that maybe in 2 or 3 billion years, if SW3 survives, will receive SW3 as it enters the inner solar system. Maybe it will wake up and put on display for somebody else. I think that would be totally awesome, and then have them backtrack the orbit to good old Sol and its rambunctious brood of planets.
Yeah, that would be awesome, wouldn't it?
I mean, Comet 91P Magchalz is thought to be an interstellar comet. It's carbon depleted more than it should be. It's in an orbit where it shouldn't have really been there. They think Jupiter snagged it as it came in. I mean, we could just throw something at that. I mean, because I read somewhere that the problem with these comets is really twofold. One, they come from any direction at any time, and two, the sheer speeds that they come in at. As you know, the escape velocity is incredibly fast, and they say that the machinery or the technology we have cannot keep up with them, or the basis is just like the hare and the tortoise sort of thing, So that's the problem they have with catching these pristine objects, which we would want because they are pristine. The ones that we see from the Jupiter family comets have been around the sun probably literally thousands of times. They're dying. They've expended all their
volatile
pristine material. But these new ones coming in like S3, showing us everything that it can have, and literally blown itself to pieces by the looks of it as well. So with outgassing events, so it's exciting times.
It is. And I think the nice thing is for us, the fact is that our equipment has leapt when you consider what our Victorian brothers and sister astronomers had. Even if you look at what W.T. Hayes, the comedian, had, he was a serious member of the British Astronomical Association, of the Saturn section. In fact, there was a storm, a white spot on Saturn, which he discovered. He followed it, he reported it, and several other astronomers looked at his information, and confirmed that yes, he had found a new storm on Saturn. And at that point, the equipment he had, it was homemade in a lot of the case, but it was considered to be very much cutting edge. Today we have mirrors which are approaching. Well, the mirror I'm getting is f3.3. I have to have a reducer on it for photography, which is fine. It'll correct all the commas on the stars and stuff. That's fine. I accept I have to have that. But the thing is, we have the CCDs. They are getting better and better. They're dropping in price. Your average everyday camera now has in most cases has a CCD in it. And you can even use that for astrophotography. If you've got a DSLR, you have a camera capable of doing astrophotography. So the cost of the equipment is coming down as everything goes. And this is probably, everybody says, oh, what did the military do for us? Well, for a start, they gave you your lovely DSLR camera, digital single lens reflex camera. That the chip in there that records the images is a byproduct of military research for spy satellites. So yeah, they believe it or not, they did you a big favor, because you're using military technology that's been released to the civilian sector, is being put to a new use. Yeah, to take pictures of planets, of nebulae, of galaxies, of comets, of interstellar interlopers. We are on a par with some of the big institutional telescopes. And of course, we have the greatest thing of all. We've got the time. They don't have it. If a professional astronomer wants to follow a comet long term, he has to come to the amateur community. And even more and more, I see 4 or 5 announcements for pro-am collaborations going on for more and more objects in the solar system. As we finally inch towards leaving low Earth orbit. Yes, it's a snail's pace, but we seem to be getting there. We are going to need more and more telescopes turned on the skies, because we need to know what's out there. We need to know more and more about the near-Earth objects. We need to know about impactors on the Moon, on Mars, on Jupiter. We can literally tag and bag on a regular basis, whereas the professional astronomer has to book time, he has to find the funds, and we do it because we love it. We love doing it. This is our hobby. This is our fun occupation at night. Sometimes it's also mentioned in quite a few divorce cases, but oh well, that's life, isn't it? But yeah, we have this ability. I know we're slightly off topic, but I think people really don't need to realize is how good things are. Oh, you don't know how good you got it. Well, that's true in the amateur astronomy community. Our equipment is a par with them. We can get video timing devices with GPS to insert time, date, GPS location, and everything into our images. Particularly for projects like lunar impactors and stuff, and for looking for impactors on Mars and Jupiter. The technology has come a long way. It used to be a very complicated system. Now you just plug your camera into this little black box. You plug your black box into your computer. It then gives you the images from your camera with a time and date stamp and everything on it. And as I say, we can do a lot of things, and I really understand a lot of the sudden demand for pro-am collaborations. I think this is the future of observational and imaging for astronomy, is that the professional community is going to rely more and more on the amateur community, particularly for solar system work, because then the big telescopes can push out to Planck time, etc., and tell us about the early universe. and look at perhaps how galaxies are formed, look at stellar nurseries, yes, I can understand that's going to be the purview of the professionals. But we're right behind them. Their technology eventually trickles down. And at the end of the day, we are sitting pretty, we're in a nice position, and we can also improve our skills as scientists, as amateur scientists, because this is something I am going to suggest in certain places. Maybe it's time there was a class that could be taken for people who want to get into the pro-am collaborations in a big way. Maybe they could put out a short course. Maybe, wouldn't that be nice if the Open University or somewhere did a short course on amateur observations and imaging for pro-am collaborations?
That'd be good, because I think people are sometimes nervous of submitting their findings because they don't think they're good enough, or they don't quite understand the format it needs to be in, or they don't understand how calibration frames work, and it can be a bit daunting for people that are fresh into the hobby. It's daunting for people that have been doing it a long time, never mind about new people.
I still can't get my head around the IC what's-its for comets. I really can't. And I think one of the things I'm going to do next year is I'm going to talk to Nick James and Dennis Bachowski and say maybe this is something could be covered in a section gathering for the section, is literally take everybody through the process. And maybe I'll also put this on. I'm going to post this on the BAA website. Maybe the sections can set up courses to allow section members, both BAA and non-BAA members, to acquire the skills to provide the scientific imaging and observational data, because that would really, I think, boost our stock in trade, so to speak.
I think it would.
What do you think, Neil?
Oh, I agree totally, yeah.
Apart from saying, Nick, get off your soapbox.
No, well, you're doing a good job, Nick. You're doing a good job. You're filling time.
Yeah. But, I think maybe, and I'm going to say this, if you're listening to the show, if you agree with this, please send messages to your astronomy club, to the association you're involved with, and try and get this laid on. I would love to be able to go to a meeting, and part of the fun would actually be finally meeting in the flesh some of the people I've got to know on Facebook, through the CometWatch section and everything. I've met a few people already from the BAA Comet section and from the Minor Planets section, and it is really good to really be able to talk about what we love, and maybe boost our skills. The more we can do as, I'm going to say, amateur scientists, and there's nothing wrong with saying you're an amateur scientist or amateur astronomer. All we're simply saying is we don't either have nice funding from a university or similar institution to do what we enjoy. It's a case of we're doing it for the love of it, and we're doing it to the best of our ability, and the offer of extra skills or improvement in skill sets is always something we should really look for. And I know I see a lot of this in the amateur radio community, teaching operating skills, getting together at club levels to help new people through initially operating and talking DX. In this instance, it will be submitting either images or submitting visual observations or sketches to the collaborations, to their own societies, even to their own club newsletters, because everything we can do to boost the level we do this at the end of the day, is fun. It really cements and binds everybody together as a serious isn't the right word. I think more as being comrades in arms.
Well, I saw Alan Chapman talk at Astrofest about some of the amateur astronomers from Victorian period, and the word amateur meant something different then. It didn't mean somebody that wasn't a professional, or that we think of an amateur as not being very good at something these days. It's derogatory, but that's not what amateur actually meant. They were just not paid. They were as good but as the pros, but just not paid. So it's good to kind of just have it in your head that amateur doesn't mean that you're not very good at something.
And I think maybe this is something we should also talk about in our posts. Maybe saying, when I say I'm an amateur astronomer, I don't mean it in the modern sense that I'm a ham-fisted bodger. I am doing as good as a professional scientist can do, but without the pay and institutional backing.
I'm a botcher at times, but
Hammer and botch it. Furniture makers to the public.
Botch it and Scarpa.
That's botch it and Scarpa.
That's better.
But seriously, I think what we have to do, and maybe this is something we can get the BAA, the SPA, to also on board with, is to actually promote the Victorian sense of the word. Because let's face it, it was the Victorian amateur scientists and who pushed us technologically forward. It wasn't institutions doing the work. It wasn't people like universities. It was people like Messrs. Lee and Enfield who took the next step, but they were doing it in their own private workshops. They came together because they figured this is probably the best way for us to do it commercially, is that we work together, and they looked at each other's improvements, brought them together, and had brought the British Army's weapons a whole lot better. They leapt forward, and that's probably why we had the Empire, I suppose, because we had people like Lee and Enfield who did everything initially in their back garden workshops, and then they would get together and say, "Oh, let's do this together," and a step forward was taken. So let's get people to realise being an amateur astronomer doesn't mean that you're I'm a bit iffy about this. No, I am as good as the professionals. I will make myself as good as the professional astronomer. I am going to study. Oh, this is going into scouting type stuff, isn't it? I will study. I will be a good scout. I'll save the Queen and everything. But seriously, that is what we need to do with amateur astronomy.
A lot of pro astronomers don't know their way around the constellations. I think they'll all be the first to admit that.
Well, because they're a lot of them are so narrowly specialised.
That's true in every scientific discipline, though. When I worked in research, I notionally worked in a diabetes research lab, but I didn't know anything particularly about diabetes. I specialised in one type of pituitary cell. So that's not a big picture at all. That is so tunnelled that it means nothing to anybody taken in isolation. So
I think that's where societies like the BAA, the Astronomical Society of the Pacific, the Astro League really do excel, is that they make everything generally available. They bring everything together so that you can see it as a broader picture. And I think the professionals, I don't know quite a few professionals, they may hit me for this, but I don't care. They got specialised. They have their own narrow little niche, and everything out of it they don't know about, and including probably figuring out the Big Dipper from the Little Dipper, Ursa Major from Ursa Minor. They wouldn't be able to tell you what constellation is, and I think that's I think that should be part of their general knowledge base. And yes, and then by all means specialise still, but let's face it, if you can tell somebody, oh, the comet is going to go through Ursa Major, and point out Ursa Major in the sky or on a chart, that perhaps will also help the public to understand. Certainly I really do need to get back to being able to do naked eye astronomy and work my way around the constellations. I got lazy. I've got to go to a telescope. I don't have to think about star hopping anymore, because I can just simply
you lose it very quickly when you don't do it. That's why I like binoculars, because up and down, left, right is the same way. So I really struggle with the inverting things idea, so I rely heavily on GoTo.
But let's see what happens. So I think I'm going to have a chat with Nick and Dennis about this. Maybe we can get them to come and do a presentation for CometWatch or something. We'll see what they say. I think it would be fun because the more you can get the knowledge out there, the easier it is. I don't do the things in the format Dennis wants, which is because I don't understand it. And maybe if a PowerPoint, there was a PowerPoint presentation on how to do it, that you can refer people to, then things would become a lot easier. But as I say, the only other thing, of course, is touch wood, S3 will come around the sun intact, and we'll get another nice display. So that's the only thing.
We can but hope.
Exactly. It would be nice. And of course, Giacobini-Zinner is doing some very nice displays as well, and that's another good candidate.
Yeah, I was going to say, before we go or whatever, the 21p, people should keep an eye on that comet about, say, mid-August time, when it's going to be very high still for the Northern Hemisphere, because that is the time when it is about 30 odd days before perihelion. It has traditionally had outbursts itself. So, and then it would start to about most of those visibility.
You've gone muffled, Neil.
Can you hear me now?
Still a bit muffled.
Oh, it's still a bit muffled. Well,
You were a little bit okay then you went muffled again. Neil, are you still there?
I am still here. Can you hear me?
I can hear you, but you're very, very muffled.
Oh,
That's better.
Connection?
That's better. That's better.
Stand still.
You were saying about 21p going
21.
into outburst.
Yeah, that normally happens about 30 days before perihelion, which would be about mid-August, and it can jump up by 2 magnitudes, which means it could get to naked eye visibility then. I mean, it's visible in 20 by 80 binoculars now. I've seen it a couple of times myself, so it's worth keeping an eye on.
Yeah, and of course the nights are drawing out.
They are.
As of the 20th, night actually really existed, only for 20 minutes, but it really did exist. So the days are getting shorter again, thankfully, and it means that we can get outside, we can start looking for some long evenings with comets, planets, constellations,
lunar eclipses,
which I can't actually see it because it's mostly over Canada for as far as I'm concerned. And that's high Arctic Canada that gets this eclipse that's coming up.
Yeah. We'll probably be cloudy, so.
There's always the internet, I suppose.
Yeah.
That's another thing, something that we as amateur astronomers can do is we can stream these events.
Yep.
So if you happen to have clear skies, link up your camera to your laptop, to your internet, and then Facebook Live it. That would be hilarious, doing a Facebook Live of, say, a lunar eclipse or a comet.
A lot of people do this. They whenever they're doing anything at the eyepiece, they do Facebook Live it. I know a few people that do the Lunar X and V live and stuff like that. It's a good thing.
Yeah.
It's just not something I ever think about doing. I'm too busy swearing at my equipment normally. But it's a good thing to do. Just looking actually at 21p, quickly going back to that, it's going to get really close to the Heart and Soul Nebula in mid-August.
Yeah.
That'd be a gorgeous wide field photo opportunity if it does brighten. So I was just quickly looking on Stellarium to look at its path through DSOs, and that would be a stunning photo if it's...
Now, you said Heart and Soul Nebula. Is it known as anything else?
NGC 1027.
Thank you. I don't know. I know the NCGs as that. It's like when somebody said the Elephant's Trunk Nebula, and I'm scratching my head. Elephant's Trunk Nebula. Or the Crescent Nebula. Crescent Nebula, I know. It's also called the Witch Head, as I remember. But I'm one of these sad people that knows the numbers, but not often the common names. because if I'm organised, if I'm doing an imaging run on a remote telescope, I'm using the NGC catalogue or the Messier catalogue. Plug that into the figures.
Well, the Heart Nebula is IC 1805, the Sol Nebula is IC 1848, and then there's a little open cluster in the middle, which is NGC 1027. So they're all in a little clump together. That would be nice.
Wow.
That'd be really nice if it brightens and is visible around then.
Well, I can certainly look for this.
That's around the 18th of August, so...
Send me some notes on those NGCs and ICs, because I haven't got any pen and paper to scribble with at the minute.
Yeah, I will do.
Because I can look ahead and see if I can get any telescope time, and maybe try and get some images. So far, every time I try to do image 21p, the scope I've been using has been shut for weather.
It's looking good. It's looking good.
So yeah, there's a couple of missions. There's some availability, so at about 4 o'clock tomorrow morning. So I have set up something for that. We shall see. I can hope, I guess. So we've been waffling on for about 50 minutes. So anything interesting to look forward to apart from S3 and 21p?
Apart from 46p later in the year, no, nothing commentary wise, definitely not.
And I'm sure we can do a show on that one.
Yes, yeah.
There we go.
Dr. Alan Fitzsimmons.
Yep. Oh yeah, that would be a good idea. Let's get Alan back. Yeah.
Yeah.
And someone's looking at me, so I'm saying no, not Alan Grant. Oh dear. So yeah, let's do that. That sounds like a plan to me. So yeah, there you go, folks. We're going to ask Alan if he'll come back and talk about that comet. Maybe we can do a 2-hour show on that.
Yeah,
that was so interesting last time.
Yes, it was. It was. See, this is what I like about our guests. We can just start. We can just drop something in, and our guests are really wonderful, and they can talk about the subject just so easily. Anyway.
Yeah, they're so knowledgeable, aren't they? It's incredible.
Yeah. Maybe we can get Messrs. Scotty, Hill, and Kowalski back as well towards the end of the year, and have some fun with those guys, which we always do.
The three wise men. We could have them for December.
I could be interested in their reaction. Listen to their reaction. We'll see it when they hear you describe them as the three wise men.
Yeah.
Well, I suppose yes, true. They are the three wise men.
Yeah.
Because they sure as heck know their subjects so very well.
They do. Jim Scott is on television all the time.
Yep, Mr. Kowalski made it on TV again about his impactor that went down in Botswana.
3 out of 3. He's doing a good job.
Yep. That's the nice thing about these guys. They are getting so good at it that even the TV is giving them airtime and giving them a chance to talk proper science and not give them dumbed down questions. Anyway, I think maybe we should wrap at this point and say, well, folks, we hope we should be back in August, and we'll look forward to seeing you then. And on that note, it's good night from me.
And good night from me.
And good